Welcome back. I'm still Dr. Platt. In this video segment, we're going to be looking at types of data and ways to properly sample data. So, two main types of data are qualitative and quantitative. Qualitative data describes attributes, labels, or non-numerical entries, and they can create categorical variables, which are just categories for things or people. And hair color, blood type, ethnic group, the car a person drives based on either make or model, the color of the car, the street a person lives on, their house street number, are all examples of qualitative data, as are a player's jersey number, a person's phone number. Though these have numbers associated with them, they are qualitative because those numbers function as labels, not numbers, where a number is something that can be compared in a mathematical way. Quantitative data consists of numbers that are measurements or counts and can be compared and ordered in certain ways. Quantitative data can fall into two categories. Discrete quantitative data is data that can be counted, such as the number of phone calls a day you make or the number of episodes of a TV show you watch, at least part of. Where continuous data is data that involves measurement. It can be fractional, decimal, or irrational. And it is, again, obtained by measuring. This would be the amount of time your TV is on during the course of a day, or the amount of time you spend on the phone. A person's height or weight is continuous data, even though both are rounded to the nearest half pound or half inch in various cases. The actual values would be continuous. When we're sampling, we're seeking to get a sample that has the same overall characteristics as the population is representing, at least for the variable we are using in our computations. This can be done in a number of different ways, either through individual selections or through selections that pass through a grouping process of one sort or another. A simple random sample is one in which every member of the population has an equal chance of being selected, and every group of a given size has the same chance of being selected. This becomes more challenging or virtually impossible to have if you have members of the population pre-grouped. A random sample simply gives everybody the same chance of being selected, but doesn't have any of the grouping restrictions. A stratified sample pre-groups people into subgroups or strata with some characteristic relevant to the study. There can be multiple subgroups, and then subjects are selected at random from each group. These strata can be represented by the grade level of a student. So if you have a high school, you separate by freshmen, sophomore, juniors, and seniors, and then from those you randomly select certain individuals. This can be done by using, say, class rank within each of the grades or an alphabetized list, assigning each a number, and then randomly generating numbers, and whoever's number is randomly selected from within their grade is used to represent the grade. You want to use a proportionate number from each strata. If, let's say, the freshmen are twice the size of the senior class, then you'd want to have twice as many freshmen in your sampling as your seniors. The common attribute can be a number of different things. It doesn't have to be class level. So in this picture, each color base represents a different strata, though they're side by side rather than vertical. And those that are sitting in the front are those that are not selected. Those that are standing on the risers in the back are those that were selected for the survey. It may not appear randomized, but once the random selections were made, I sorted them out based on selected versus non-selected. A cluster sample has some attributes that are similar to the stratified sampling in that the population is pre-sorted into different groups, except in a cluster sampling, it is based on more naturally occurring subgroups, and many examples would have geographic regions, such as if a town has a waterfront area, a more upland area, and a hilly area, and want to see how they fared in a particular series of storms. They could identify blocks or neighborhoods from each of those three regions, and then go door to door and survey every property in each one or in those particular blocks. So they take two blocks from the waterfront region, 4 blocks from the middle upland region, and 2 blocks from the mountain regions to see how they weathered those storms, and ask everybody on those blocks. So certain blocks are chosen, as seen here. The yellow and gray blocks, everyone seated, they're not included in our survey. Where everyone in our green and blue are standing, they are included in our survey. A systematic sampling takes has everything put into a particular order, into some order. That order should be randomly assigning people to some extent at least. And then once you have that order, you randomly pick a starting person and randomly select a interval. So in our picture here, the 4th person in was included, and then every 3rd person beyond them was included in the survey as you go down the street, with these people waiting perhaps for a parade to come through. A systematic sample, if you choose to do in the correct place, can allow for a pretty accurate set of data. It is often used in manufacturing processes where the quality control for Coca-Cola, for example, can use this method. A convenient sampling uses whoever is convenient. So in this case, we have a bunch of people spread out. They would be hard to get for our sampler. But these people who are sitting around having a picnic, they could walk up to, or interviewer could walk up to, and talk to that whole group and get their opinions much more conveniently than others. If these picnickers have a different idea of how the park is used compared to our more dispersed walkers, that could make a very different scenario and make this a non-representative sample. Voluntary response sampling. You put a survey out where anyone can pick it up, fill it out, and put it away, or put it in the box. And in my opinion, and in the opinion of many, this is a very unrepresentative sample because the researcher has no control over who self-includes. Sampling can occur without replacement, where an individual once selected is not able to be reselected, and the population that can be sampled is being modified each time a selection is made. That was without replacement. With replacement, once a member is selected, they can go back in the pile and can be reselected so they can appear more than once in the sample. So without replacement, the population of possible sampling is being changed every time. With replacement, it's going back to what it was every time. When a sample is large enough, selection with or without really doesn't make a big difference. Whenever you do sampling, you will always have errors, and a sampling bias is one type of error, a type of sampling error in which certain members of the population are overrepresented and others may be underrepresented. Non-sampling errors occur when the sample is biased or for one reason or another without it being associated with who is selected. Okay. And the bias or error is simply the difference between the value that you should have gotten from a population and the value that you did get from your sample. This bias is very rarely, if ever, known, but it can be assumed to exist because we have to assume, because in those cases where it is known, it has been found. So we will continue with our levels of measurement in our next segment.